Okay, here on our final example for this lesson, we're going to be confirming solutions using technology. And I will try not to rant about technology while we're at it. The square of the time it takes a planet to orbit the sun, t, is proportional to the cube of the planet's mean distance from the sun. This relationship can also be written as t equals the square root of a cubed, where t is measured in years and a is measured in astronomical units. It's just the distance from the Earth to the sun. Okay, so they're saying the time it takes, the time is proportional to the cube of the mean distance, so the cube of a, the square of the time. So if we squared both sides, if we had t squared, that would equal a cubed. So t squared equals a cubed. Solving for t by itself, we get t equals the square root of a cubed. Yeah, so they are saying, their expression is saying this, t squared, the time squared is proportional to the distance cubed. Now, the reason why that is itself a fascinating topic of physics, dimensions, motion, kinematics, all sorts of good stuff. We're just going to go into the math side of it, checking it with a calculator. So, as we have in the past, if we have an equation that says that the orbit of Mars is 1.88 years to get around the sun, we want to find the mean distance from Mars to the sun, well, we'd have 1.88 needs to equal the cube root of the square root of a cubed. Square root of a cubed. And I guess I'll put x so that it likes it better. Okay, so here is my graph, matches up to what they expect to see. And the crossover is at 1.523. So Mars, therefore, is 1.523 times further away from the sun than we are. Okay, 1 astronomical unit is our distance from the sun, our mean distance. We travel on ellipses, so we don't have a constant distance from the sun. But our average distance from the sun, if you multiply that by 1.5, roughly 50% more, you'll get where Mars is at. Okay, and that would be confirming this measurement using a calculator. That's what they're saying we're doing. We're confirming a solution. The solution has already been found. This relationship through investigations into physics has already been determined that this is a true statement about the motion of planets, the motion of orbiting bodies more generally. And since the measurement of Mars through the sky has been done, we've seen how long it takes to go around the sun, we can confirm that this is true using a graphing calculator by writing out this equation, by saying that the time was indeed 1.88 years that's been measured, and we know that ought to be the square root of the distance cubed. Okay, we can go through, therefore, on a graphing calculator to easily find what is that distance, 1.5 astronomical units. All right, the lights are shutting off. It's time for me to get out of the building. The lesson is over. Thank you for sticking with it. I hope that I have filled you with a sense of distaste for technology. I probably haven't. You probably like using it just like everybody else does. But in general, like I said, don't get overly reliant on the technology, even though it's a wonderful thing and it's wonderful that we can find solutions and check solutions so easily. You will always be more proud of yourself if you can do it by hand, if you can figure these things out by hand, and if you just use these as quick tools to confirm solutions rather than generate answers in the first place. Okay, because it's the difference between understanding why that answer is true versus just knowing that it's true because some computer told you it was true. All right, that's my soapbox time. I'll talk to you in our next lesson. Have a wonderful day.